In this next example, we will simplify a few expressions using the exponent rules for both multiplication and division. We need to make sure we keep in the back of our minds the order of operations: parentheses, exponents, multiply, divide left to right, and then add and subtract left to right. The truth is, these exponent rules only apply for multiplication and division, and so we won't have to worry about the addition and subtraction step. In part A, we have the quantity p squared t to the fifth in parentheses raised to the fourth power divided by p times t to the 20th. Order of operations says I should do what's in the parentheses first, but since that's p squared t to the fifth and they have different bases, I cannot do anything inside the parentheses. So the next thing order of operations says is to take care of the exponent. In this case, that outer exponent of 4. So the first thing I'm going to do is keep the denominator the same, p times t to the 20th. And up in the numerator, I'm going to apply that outer exponent to both the factors on the inside. So I'll have p squared raised to the fourth power times t to the fifth raised to the fourth power. Now using my power to a power rule, p squared quantity to the fourth, 2 times 4 is 8, and t to the fifth quantity to the fourth, 5 times 4 is 20. So that gives me p to the 8th, t to the 20th, over p times t to the 20th. We've now taken care of the parentheses and that outer exponent. What we now need to take care of is multiplication and division. P to the 8th divided by p, you want to remember that p in the denominator means 1p. So p to the 8th divided by p, one of the p's from the numerator cancels, leaving me with 7. T to the 20th divided by t to the 20th, I could write that as t to the 0. There are 20 t's in the numerator and they all canceled with the 20 t's in the denominator, so there were no t's left. But t to the 0 we know equals 1, so I'll simplify that simply down to p to the 7th. It is important to point out that we took 4 steps to simplify that expression. The more comfortable you become with the exponent rules and the process of simplifying, the more you'll be able to do in your head, and the faster and shorter your work on paper will become. This could have actually been simply a 2-step situation. We could have jumped from the original expression to applying that outer exponent and multiplying at the same time, down to the final answer, where we simplified the p's and the t's independently. In part B, we have the quantity 7 to the 8th m to the 5th, all divided by 7 to the 5th m squared, and all of that is in parentheses raised to the 6th power. The more you work with the exponent rules, the more you'll realize there are various ways that you can approach the same problem. But as you are just beginning these rules, it is important to keep to order of operations. Now the order of operations here says p for parentheses. I need to try to simplify what's inside the parentheses before I deal with anything outside of it. 7 to the 8th divided by 7 to the 5th tells me 5 of the 7's from the numerator will cancel, leaving me with 3. M to the 5th divided by m squared. That square tells me that 2 of those 5 m's will cancel, leaving me with 3. So what I'm left with in just simplifying inside the parentheses is 7 to the 3rd, m to the 3rd, all of that quantity raised to the 6th power. Now we have a product inside parentheses raised to a power outside. We will apply that exponent of 6 to each factor on the inside. So 7 to the 3rd raised to the 6th times m to the 3rd quantity raised to the 6th. Again, this brings up our power to a power rule. 7 to the 3rd quantity to the 6th is 7 to the 3 times 6, or 18. M to the 3rd to the 6th, again, 3 times 6 is 18, so we have m to the 18th. So our final simplified version of this expression, 7 to the 18th, m to the 18th.